Hey everyone, welcome to the very first Duende live stream here, where we try to bring you the best .NET security content in the space. So this is going to be exciting. Just a slight introduction to the topic today. Are you storing OAuth tokens in the browser to power your spas written with React, Angular, Vue, or for .NET folks, Blazor WASM? Well, today we're going to show you why that's probably not a great idea. But before we get to that, let's do a little bit of housekeeping because we kind of always have to do that here in live streams. So first of all, if you're watching this live, first of all, thank you so much for joining us live. If you haven't noticed already in the YouTube UI, there is a live chat over there on your right. So feel free to communicate with Duende community folks. We also have Duende employees there, so if you have any questions, please feel free to ask and we'll try to answer them there. A common question we always get on live streams, is this being recorded? Yes, we understand life happens. You got to go pick up the groceries, the kids, take the dogs for a walk, or maybe do a little bit of work, go to a business meeting. So if you need to do that, and you need to kind of drop off, know that this video will be published to our YouTube channel. So be sure to like, subscribe, comment on this video, and hit that notification bell to, get notified when this video is available later. On that note, let's introduce our speaker for today. You probably already see him there in the live stream. But our speaker today is Erwin. Erwin van der Valk is an experienced software engineer who is passionate about architecture and web security. He is a principal engineer here at Duende Software and the product owner of the product you're going to see today, Duende Backend for Frontend Security Library. So on that note, let's welcome Erwin. Erwin, how are you doing today?
Doing great. Thank you so much for the introduction.
Yeah. So again, folks, if you're in chat and you're seeing something that Erwin is presenting and you have a question, please feel free to ask it in chat. But on that note, I'm going to hand the stage over to Erwin. Erwin, if you need anything, I'm here. Here to help.
Perfect. Thank you so much. All right. Well, welcome, everybody. As mentioned, we're going to be talking about access tokens in the browser and why that may be a bad idea. To do that, I have, especially in part 2, I have a somewhat vulnerable React application that we're going to be dissecting a little bit and see what the problem actually is. Then in part 3, we're going to look at, well, how does the BFF security pattern, as mentioned by the IETF, helps. And in part 4, we're going to look at the Duende BFF security framework, and we're going to apply that to actually rescue the React application. Then in part 5, we're just going to look at what's next for the BFF and what's upcoming on this particular front. All right, let's look into it. Access tokens in the browser. We've been doing that forever, right? Since 2000, I think 2012 already, this has been happening. But let's look at access tokens first. Just a quick recap for people who may not be fully aware of what access tokens are. Access tokens, they contain claims about who you are and what you can do within an application, right? Now, when you're talking about claims, anybody can make a claim about anything. So the trustworthiness of claims is very important, obviously. So when you have an access token, it's very important that it's provided and signed by a trusted party, typically an identity provider that knows something about the users. Why does it need to be signed? Well, obviously, you don't want anybody to tamper with the claims that are in those access tokens, right? So if it has a role that says this person is just a regular user, you don't want to change that accidentally to an admin or something. So by using signing, we can prevent those kind of tampering with that. Now, those access tokens are very typically used to authenticate requests to services. And within those services, then, they provide access to your valuable resources, right? The things that you want to protect within your application. So yeah, it's pretty clear that we want to protect these things. They're valuable for us. Now, those access tokens are used inside of browsers. So if we look at browser technology nowadays, well, a browser is designed to execute code in your users' computers. And that execution environment is very different than having code run in a data center, for example, in your servers. The trust model is completely different, and also, of course, how it works. Now, fortunately, browsers have a very good, what we call a security sandbox. But the goal of that sandbox is to prevent one site from influencing another site. What is not the goal of that security sandbox is to provide boundaries within a particular site. So if you have within your site script or things that are loaded from multiple sources, then yes, it will be merged all together in a single application. And that particular thing is typically being attacked by malicious actors. Because if malicious code is inside of your application, it can do exactly what your own code can do. And that's really important. You might try to hide information, access tokens somewhere, but if your code can access that, malicious code can access it too. And if you can't access it, then very likely it's no longer useful. So what attackers will do, they will try to inject code into your applications to steal your access tokens. And that is obviously something that we want to prevent as developers. Now, we've known about injection attacks for a long time. And if you're, a reasonably experienced developer, you know how to protect yourself against them. But even though that's the case, injection attacks are still incredibly common. If you look at the OWASP top 3, it's still there, right? Injection attacks happen all the time. And script injection is just one of those vectors that is very, very common. And unfortunately, the blast radius could be quite big. But even if your application is developed perfectly, you are still relying very likely on a lot of libraries from third parties. Just look in your Node.js folder, how many packages are there? There's hundreds or thousands is very, very, very common. So supply chain attacks, if one of those libraries is compromised, then your application immediately in the browser is compromised as well. And even if that's not the case, even if you vet all of those libraries, there might still be other cases. A while ago, for example, Spectre was out there. And Spectre was a processor-based vulnerability. And there have been proof of concepts where they used Spectre from one website to get access tokens from another website. So to bypass that security sandbox. So just to recap, there's a lot of ways how browsers are being attacked in this particular regard. So if malicious actors are trying to steal your access tokens, well, there's various ways how that can typically happen. The first is they might be able to just grab an access token once. And that's kind of like a drive-by attack or something, right? They capture it once, and an access token is typically not very long-lived. So all that the attacker can do with that access token is quickly grab some data as much as they can, and then already, the access token has expired. So the opportunity for misusing this particular, type of vulnerability is not as great. But if you have a bigger problem inside of your application, if you're constantly leaking new access tokens, then it's kind of like you've left all the windows in your house open, right? Attackers can just come and go, and they might just go in and examine your application very, very deeply. But there's even a worse situation than that. And that is if they would steal your refresh tokens. Now, what are refresh tokens? They are long-lived tokens that are used to acquire new access tokens. So if they steal a refresh token, it is literally like somebody, the attacker is just in your house taking their time. Now, why would they do that? Well, they want to go through all your dirty secrets. They want to find not just the vulnerability that they already have to get the access token and to get access to all your data, but they want to probe your application at their leisure for other vulnerabilities as well. They want to escalate to maybe, server-side code execution, or, and that's much harder to do if they can't even get into your application. So, of course, on the right-hand side, the refresh token theft is something we want to avoid at all cost. Now, the answer to that is obviously to stop using tokens in the browser. This is not a new thing, actually. I mean, the IETF has been talking about this for quite a while, and even I looked it up. The Duende BFF product has even the first preview of this was already in March 2021. So this is not a new thing, but it's still very, very relevant now in 2025. Even so relevant that in March, so a couple months ago, the IETF came with an official recommendation. Now they do that periodically, right? They come out and they come with a document that they call a best current practice document. And in there, they're capturing, okay, what's the state of the landscape? What are things that we are seeing in the world? And what should we do to prevent those? Now, on the right-hand side, you see a screenshot of this particular document, and you see, the different ways how applications are being attacked, the consequences of that, and a very good solution to that, which would be to apply the backend for frontend pattern. Okay. Now, I mentioned that this is a very relevant situation. Now, just a couple days ago, I saw this particular article out there. The OneDrive file picker apparently has a pretty major flaw in it, and it's being used in a lot of applications, including ChatGPT. So imagine the following situation. You're on ChatGPT, you want to select a file to analyze by it, and you think, obviously, that you're only giving the large language model access to that one file. But unfortunately, you're giving it access to your entire OneDrive. But that's not the worst, right? That access token isn't stored securely server-side or anywhere. No, it is just stored in plain text in the browser. So if you have a web app where somebody has built, and you don't know what other scripts are running into that thing, and there's a OneDrive file picker there, as soon as you've selected a file there, they have access to all of your files. Maybe right now. I mean, ChatGPT is training the data on your things in OneDrive. I don't know. Maybe. Probably not. But this is a pretty significant risk. And if you look at applications, many applications that have this vulnerabilities like this inside of them. So let's have a look at a real-world application. Now, I mentioned earlier, this is a slightly vulnerable application, so please don't do the things that I'm doing here at home. But I do, of course, add some things for demo purposes. So if I show the application to you, there are 3 parts of this. Now, as you can see, maybe for those people who are .NET developers, I'm using Aspire to run various hosts. You don't have to do that. It could have just been me running an npm run command and running a backend somewhere else. Aspire was just an easy way to get started. And in here, what we see is that we've got a front end, and the front end users will go there. The front end then calls some services on the back end. And also, for demo purposes, I needed to create a second service. So I have another service here, the profanity checker. We'll get into why that is there in the first place. But if we navigate to the application, this is what it looks like. Now, apologies already, I am not a front-end designer. I am not a front-end engineer that much. I've done my best to make it look okay-ish. Some front-end people might cringe. I've done my best here. But the goal is here, you go here and you can leave reviews for Webcast. And hopefully, of course, everybody will leave a really nice review for me as well. This application uses OpenID Connect to log in. And we're using a demo version of Identity Server to do that. So if I log in as Bob, I'm now logged in, and now I can start adding reviews. Let's not add these passwords to Bitwarden. And you can see, okay, we know who we are now. There's a logout button now, and I can start adding reviews. So for example, this is Erwin, then software.com, and we can do something like best webcast ever. Maybe, we'll see. And then it adds it, and there's a link there. Now this, if you look at the traffic here, you can see that every time we're making calls here, so for example, if I add something here, you'll see that a call has been made, and you can see that access tokens, well, this is the list call, access tokens are traveling across the wire. So if I take this access token, if I go to jwt.ms, I can paste that in. I do need to remove the bearer string here, and you can see what's actually in here. Now, this is all kinds of information about the currently logged in user. their user ID, their name, their email address, who actually created this token, and what you can do with it. That's typically under scopes. I'm able to access a particular API. That's the information that we're sending with every request from the backend to the server. Okay. Now we can look at, okay, are there ways that we can attack this application? Now, of course, I'm hopefully a reasonable developer, and I've tried to make this a safe application. So if we're looking here, if I do my white hat hacking here, I add my script tags here to see, is there a vulnerability? I submit it, and they're all nicely encoded. There doesn't appear to be any clear vulnerability here. I mean, if I click on the website, it doesn't work, doesn't alert anything here. So good, that's safe. But there is still a vulnerability here, obviously. One of the vulnerabilities that I recently learned about is that you can hide things in links. So for example, if I do something like this, beer, click here for free beer, and I just click a random link. Now, this is a website, click here. What is yours is now mine. What has happened? Well, let's have a look in the console window here. Hey, here's the access token. Now, of course, I'm logging the access token here to a console, but it would have been trivial for me to send this now to a backend server. And right now, immediately, I've got a one-time token theft. For every person who clicks this link, I'm stealing their access token. So you can imagine that that's already a problem. And that's kind of weird because, like I said, as a developer, I try to do the right thing here, right? I'm using React, and React already does, by default, some things with regards to sanitization. And you can see that because, for example, where I did the name, right, the name was automatically by React HTML encoded so that there was no script injection attack. But a link, an href here, is not automatically encoded. So you can do things, I don't know if you've seen that, this is actually a JavaScript link, JavaScript semicolon. Now, very, very true. React nowadays is warning about this, right? A future version will block this. So sure, they're going to do this. And I don't know if Angular or Svelte or whatever framework is blocking these things, but it is a risk. This is just one example. So let's look at other ways of attacking this application. One of the things you might have seen here is that, again, I'm trying to do my best. There is this dangerously set inner HTML, but I'm sanitizing the text, right? The actual control that I'm using here is a rich text editor. So if I do something here, hi, I can do bold. No, that all just works, and it just puts it there nicely. So I should be safe in that regard, right? Well, maybe, but maybe not. Let's have a peek. One of the things that, when I've been working with some hackers as well, is that they typically try to bypass all the front-end work and just directly post things to the server. So here's an example of doing that, right? It's literally just we're doing a call to this particular URL, we're passing along the access token, and we're just bypassing the UI completely. So let's see what happens then if I do this. Okay, review submitted. I do need to refresh the page. There it is. There's an image here, and on that image, there's an on error thing. What's that on error thing doing? This doesn't look like an access token. What is that? That's a refresh token. So right now, this particular script, for every visitor, I can reload this page. For every visitor, it's taking the refresh token. Now, what can I do with this refresh token if I'm a malicious actor? Well, let's see. Right? Oh, here's the application running. I have here. I've got a little script here that says refresh token. And if I paste that in here, it is going to use that refresh token to get a new access token. Now, there is a refresh token rotation going on here. So every time I'll get a new access token. Right? So yeah, Now you've effectively created a way for a malicious actor to just take that access token and keep stealing and stealing and stealing it. Now, some people might say, well, using this access token invalidates it. So the user will automatically be logged out now, and they will log in and they will invalidate your access token. But they can just grab this just on the moment when they're logging out, and then you're still screwed. So the refresh token rotation does provide some form of extra security, but definitely not enough to make this safe. Okay, so in this particular application, I've shown two ways how just a small problem and can cause you to either leak access tokens or refresh tokens, and that attackers can abuse that. So let's look at now the BFF pattern and how that can help. Now, again, right, the BFF pattern, by the way, the BFF pattern is quite a lot older already. And it didn't have anything to do with hiding the authentication bits. It was already proposed to say if you're building different kinds of front ends, so for example, a web front end, a mobile front end, to create a BFF specifically for that purpose. So when I'm talking about the BFF pattern as the IETF is documenting it, I typically tag the word security there. So BFF security pattern, so that we know that it's not just a backend for a specific front end, but we're also doing some security specific things. All right, now this diagram on the right-hand side, that shows the entire pattern, but let's just walk through it in chunk by steps. So the most important aspect here is to say we're not letting the browser-based application, the JavaScript, if you want to call it like that lives here. We're not letting that do the OAuth flow. We're moving that to the server. And the server will initiate that, and it will call the identity provider to get a new token. Now, the browser is absolutely still involved here. You will see redirects, and we've all seen these redirects, right? Where you go to the identity provider, that's where you're filling your information, and then you're redirected back. But the way that this works is that no access tokens go through the browser. Those access tokens are exchanged directly, and it's only a code that's exchanged here. So this is much more secure from the browser's perspective. Now, after we've done that, the browser-based application still needs to be able to trigger the login and trigger the logout. Now, that's a lot simpler now that we've moved the OAuth flow to the server. So all that you need to do is redirect to the login endpoint. And if you want to log out, you also have to redirect to the logout endpoint. Now, the front end also would probably like to know who is the currently logged in user and what are his permissions, what are his roles, and that kind of stuff. So you also need some kind of endpoint to query the authentication state. Now, this is very different from getting the access token, right? We're not returning the signed access token. We're simply saying with an authenticated call, for this particular logged in user, what's his name, what are his claims, and you can use that in the browser to hide things, show things, and optimize the user experience. After that, very importantly, when you've completed a login flow, we somehow still need to authenticate all the requests that are going from the browser to the server. And we're using cookies for that. Now, cookies have been around since forever. Basically, the beginning of the web already had cookies in there. And if you use a specific kind of cookies, which we call HTTP-only cookies, that means is that while the browser is storing it in a cookie jar, the browser-based application, so the JavaScript, can't access it. And that's a very important thing, right? The browser still needs to send some information to the server to authenticate it, but you don't want that information to leak out. So it's perfectly fine to store the access token inside of that cookie. There's no problem with that. It is just you want to make sure that the JavaScript can't access that cookie. Now, on every request that you make after you've set the cookie on the same domain and origin, the cookie will just flow automatically and every request will be authenticated. But there's one thing you have to watch out for, and that's what we call CSRF protection, or CSRF, cross-site request forgery. Now, your browser already has some form of protection built in to say, well, this request from one web page or one site can or cannot go to the other site. But unfortunately, there are a couple of gaps in there. And you want to protect everything. You just don't want to leave any gaps out there. So you need some form of what we call CSRF protection. Now, I'll show you in a minute what that looks like, but it's really simple. It's really nothing to worry about. You just have to enforce it. Now, if you have just a backend system with a set of APIs, you don't need any proxying. You can just call directly from your browser-based application to that. So that's what we call, connecting to local APIs. But if you have more than one API surface, imagine you've got several other services. For example, one that I added was the profanity checker, right? Then you do want to make sure that all the traffic flows through your BFF to external services. And the reason for that is that the browser-based application has only one way of authenticating requests, which is cookies. And you don't want all these individual services to have to understand these cookies. Maybe they can't even receive them because they're on different domain names. So to solve that, we have to exchange the cookie inside of the BFF for an access token, and then use that access token to access the external APIs. That's what we need to do here. And that's very important when accessing external APIs. Now, this, by the way, does mean that the BFF becomes a central point through which all the traffic flows. So a very effective proxying mechanism is, of course, very, very important here. Now, server-side session management is optional, but it is very powerful as well. Earlier, I mentioned that we can store inside of the authentication cookie, we can store also the access tokens in there. But the downside of that is that we have no way of revoking sessions or to see how many sessions we have active. Now, the benefit of doing that is that your authentication is completely stateless. We can just simply observe the authentication cookie, and by looking at the information there, the claims in there, we know what the user can do. But if you want to, you can also store those sessions in a database. And when you do that, there's two benefits. One is you can see how many users there are, and you can also log them out remotely, because deleting your session from the database immediately signs that person out. Their cookie is no longer valid. So you have more control at the expense of storing things, making it no longer stateless. So it's a choice. You can do either left or right. Once you've decided, okay, we're going to go for a BFF, there are various ways how you can host this. Now, in our documentation, we have a number of these patterns listed out, but this is my personal favorite. Your users directly from your browser-based application, they go directly to your application, and that's just the URL of the BFF. Now, the first request will also always be the request for what we call the index HTML. Now, I personally don't like to bundle all my static content inside of my application because typically they have a different lifecycle. And for performance reasons, I actually want to publish those static content to a CDN. So the way that you can get around this is that first request to get the index HTML, you can get that from the CDN and you proxy it back here. But in that index HTML, all the other links, so to script assets, to images, they will be pointing directly to the CDN. So from that point onwards, the browser just gets them from here. But any API call, and of course those API calls are the ones that we really want to secure, they will go directly to the application, and therefore they are secured with the cookies. So I very much prefer this pattern, and I'm also going to show that in a minute. So like we said, Duende does have a product offering for this. It's what we call the Duende Backend for Frontend Security Framework. It's fully spec compliant, and it just makes your life a lot easier. And it just works very well with various front-end frameworks as well. So we're going to see that in a second. Okay, let's dive into applying the BFF to this existing solution here. Okay. There's a couple of things I need to do. I need to do a couple of things on the server, and I need to do a couple of things on the client. First of all, I have Visual Studio here. I'll stop it for a second so that we can have a look at this. And The first thing I need to do is to add the packages to my BFF. So I go to the backend. Right now you can see that we're using the Microsoft library for bearer authentication. And that's logical, right? Because initially the front end was just sending a bearer token to the system. And we are saying here, yes, we're trusting tokens from this particular source, and that's it. But now we're going to change that. So we'll remove this and we'll replace it with these two packages. Now, if you're only building local APIs, which we saw earlier, you only need this package. But if you're also doing reverse proxying, we internally are using YARP, yet another reverse proxy for the proxying. It's Microsoft's proxy and it works really well. So yeah, you do need this particular package then as well. And that's what I'm going to be demoing here. So I've now added these two. Now, of course, I need to change the authentication in the BFF. So let's have a look at that. If I go there, there were two things that we really want to do. We're going to get rid of this and get rid of this as well. We need cookie authentication because every request will get a cookie. And of course, we also want to have a way to trigger the OpenID Connect workflows, and therefore we need some information. Now, this information was in the client, and I'm going to show that as well in the React front end, and now it's been moved to the back end. One very important distinction, in the front end, you don't have a client secret, obviously, because otherwise it wouldn't be a secret anymore. So that's a public client, and here we're using a confidential client, which is just much more secure. Okay, so I've added the authentication now. Then there are two things I need to add to the pipeline. Add BFF, use BFF. Now it says here use middleware. This actually prevents serve text. And we'll see in a second how that works. And I need to add what we call the management endpoints. Now, those management endpoints are actually the login, logout, and user endpoints. So now that I've added these three things, we can already log into the BFF. I can show that. Where is it? Here we go. Starting up. If we go here. Now, I won't go to the front end. We're just going directly to the BFF. There is no index HTML yet. We're going to do that in a second. But if I go directly to the login page, BFF/login. Now, one thing I forgot earlier is to log out of the previous one. And I'm using the same identity server. So if I go here, I still have a cookie on the other side. So it's going to log me in automatically. No, it's not. We'll get to that in a second. But I mean, I should be able to log in already. All right. Did I stop it? No, I did not. Let me stop it. So let's add some other stuff. I mentioned that we also need to create a I want to proxy the index HTML. Now, why do I want to do that? Well, the index HTML is, of course, the first entry point so that we see the nice page. Locally here, I'm working with a Vite React server. I'm going to see that thing in a minute. But one of the nice things about that Vite React server is that we can, it has all kinds of nice things like hot reloading, and it's just a really nice developer workflow. And I would like to preserve that as much as possible. Now, there are two ways typically that people do this. Way one is they first let the Vite React server, the Vite server first. That will be your entry point. And then proxy things to the BFF. But that's very different to how the application would run in production, because in production, there is no Vite React dev server. So I like typically to turn that around. What I typically do is I say that there's a catch-all route. And the reason why there's a catch-all route is that usually the front end is doing all the routing, but you still, for every, if you reload your page, you still need the index HTML to be served. So that's why if there's no API that matches this, we're just going to go to this. And all that you need to do there is to forward all the requests to that dev server. There's a little bit of ugly code here. It's not the important bit what that ugly code actually looks like, but it's literally just doing a proxy to my React dev server for all of the files, including WebSockets, including everything. So now that I have this, in theory, hopefully, if I didn't make too much of a mistake, then I should be able to go to this, log in again. Now if I go here, it is still not showing my index.html. That is lovely.
Erwin, did you remember to call add BFF to the services?
You are absolutely right. Thank you very much.
See, this is why I get paid the medium bucks here at Duende.
Yes, exactly. Now, the error I got earlier, and this is also, thank you very much. Yeah, the first thing you obviously need to do is we do need to register some things in the BFF as well. So add BFF registers all the services that are needed, including that one service that we had there. And add remote APIs adds all the infrastructure needed for proxying. And that's why, of course, the index.html wasn't proxying. If you don't do anything with remote APIs, you don't have to do, obviously, this second line. Thank you so much. Now, fingers crossed, demo gods, be with me. There we go. What do we think? It's going to work? Of course not. Why not? That's lovely, but BFF/login is working. Is it possible that...
Is the Vite server running as well?
The Vite server is running because I can get here. This is interesting. Well, did I add this in the right place? Let's see. It's always fun to debug things in when we're live. I'm just going to do it one time, and otherwise, I'm just going to. No, it is not finding my index.html. It's not proxying to it. This is lovely. Well, demo gods are not with me, unfortunately. We'll get that to work in a second. Okay, so let's move over to the front end now. To the front end, because there's a couple of things there that we need to fix. Here's the front end code that we were talking about earlier. And in the front end, the first thing I need to change, and actually the first thing I need to show, because I haven't even shown really how the backend, the front end was working, is how we're going to remove the authentication library that was used. So what we're using here is a very popular library. It's called React OIDC Context. And the nice thing about this is, in React world, it adds an authentication provider. It wraps the entire application in an authentication provider. So now anywhere in your application, you can say trigger a login, trigger a logout, or get the authentication state. And that's definitely something that we want to keep doing inside of our application. It's just we no longer want to use this information. We want to offload that to the BFF. So let's have a peek where we do that. Got here an authentication provider. So let me add it. BFF auth. Oh, if I can type. All right. Okay, what does this thing do? It's not that complex once you see it. It literally just wraps the application, all the content in here, with some contextual information that you can then request. That's what you see here. And very importantly, it queries what we call the /BFF/user endpoint. Now, remember that I said that we needed to do some kind of CSRF protection and that there was a really easy way to do that? Well, the really easy way to do that is just by adding a custom header to the request. And it's not just adding the request there, it is demanding that that custom header is there. That's what we really need here. So this particular thing says, give me, so the server, whenever there's an API request going along, the server is saying, I must have this specific header. And you can rename this header to whatever you want. But by demanding this, the specs that the browsers are built on will make sure that you're safe from CSRF attacks. I won't go into the actual details about this, but Just remember, this header is really, really important to send along when you're using the BFF authentication framework. Okay, so we've got that. So now I've added the context there to the context provider, but we're not using it yet. So let's do that. It's not that difficult. Oh. Just go, sorry, 1 second. The way that we do that is we get rid of the other provider that we had, and we're now simply saying, use this auth provider and wrap it around the application. So now the application, if they're getting this auth provider and not the previous one, will just be able to do the same things. For example, I'm going to replace it here as well in the app.tsx. So we're not using this one anymore. We're now using, we're using this auth provider. And I can still do this type of stuff. If the user is authenticated, then show the review form. Otherwise, don't show it. And that's kind of important, right? I mean, depending on that, you're definitely going to make decisions. I can also ask, well, who is the current user? And we'll show that in a second. Another thing is the authentication buttons that we had at the top. I've created a page for that. And you can see here that, you know, I'm still using the OIDC context library. We're going to remove that in a second. But here, when you want to trigger the sign out, or when you want to trigger the sign in, you have to call some logic that does all that complex token exchange in the browser. We no longer need to do that. All that we need to do now is just do a redirect. So for a login, we simply say location.href go to /bff/login. For a logout, we also go to a logout URL, but the logout URL, we want to prevent people from accidentally signing us out. So we get one with a token on it. And that's just stored inside of your user profile as a claim, and we can capture it like this. And then showing somebody's name is just exactly the same as it was before, just user.profile.name, and I can just access that as well. So that's kind of nice. What else? Okay, now, of course, I've now said we're going to, you know, the login endpoint is there, the logout endpoint is there, but the actual calls to my backend are still using bearer tokens. And those bearer tokens are still coming from this library. And obviously, we no longer want to do that. So I'm going to replace that with this. What that means is that we're using, you don't even need this at all. It's the downside of copying and pasting. So every request now that we're doing implicitly already has the auth on it, because it's just the browser that adds the cookies to the request. But this header is still very, very important, the XCserve header, because if I don't provide this header, the server is going to say, don't accept these calls at all. So that's very important. This thing needs to be added here to every request that we want to make. And if you forget to do that, you'll see a clear error message in your log saying, oh yeah, you don't have access. Okay. Did I forget anything? I did the auth buttons. Oh yeah, there's one other thing that I need to do, because we had a profanity checker in there, and unfortunately I forgot to demo it, but the idea is that every word that you type, I wanted to check it for forbidden words. And that is done in the review form. And this is an example of, okay, before we were going to a specific port, the profanity checker here went to this particular port, and that is not the port of the BFF. The port of the BFF was 7071. So if I go there now to 7071, that will all just work fine. Turns out that I had forgotten in this particular example to use fetch with auth. I could have done that, but I forgot to do that. So here I also need to add the CServe header. And now the request from the front end is going through this check as well, and we can see if that works. Now, I've been talking for a long time, hoping that magically the problem I was facing here resolved itself. It's good. It did, because now I see what the problem is. I don't know if somebody else spots it as well. My app.run is before the proxying. It should have been after the proxying. Great. I don't know. I can't see the chat window here. I don't know if somebody was yelling at me already. Erwin, you did it this way, you silly person.
Nope, it was all you, Erwin. You solved it. And
well, let's just keep the fingers crossed now, because I mean, I most certainly hope that now it is working. So I go here. I put a breakpoint in there. That always keeps me on my toes. No reviews yet. I'm logged in. It's working. If I click log out now, obviously, right? Then if we go back to the application, I'm not logged in. If I go here, Bob, whoop-de-doo. So that works, fortunately. And you'll see that if I now go to the network tab to actually get the list of reviews, we're not sending across that access token anymore. We're just sending across a cookie header. So we're secure that way. And nobody can steal this cookie header now anymore. Sorry, nobody can steal those access tokens anymore. So we're perfectly secure from that. So if I now log in here, say, hey, this Erwin, doesn't matter what I fill in here, Duende Software. And let's not do this again. Let's use MSAL. That's the profanity checker. You know, if you remember in the previous slides earlier where I mentioned that that security vulnerability with OneDrive, MSAL was used there. So a little joke there for us security users. But hey, so that's the call to the profanity checker. It's saying now, don't let you in. And if I remove that, the review is down. Whew. Fortunately, we got that to work. Okay, so just a quick recap. On the back end, you just add the BFF library. You configure the OpenID Connect workflows, and you add the BFF endpoints and security middleware in the right place. Very important. On the front end, we remove the OpenID Connect workflows. The login and logout pages are now just links. We added some user state management, and we added those CSRF headers that protect us from cross-site request forgery attacks. And that was it. Now, there's no way that people can steal our access tokens anymore. All right. So you might be wondering, well, okay, this looks nice. We are fully spec compliant with the BFF. So you're done, right? System is done. No more work to be done. Well, our work is never done, obviously, but we're very heavily working now on BFF v4. BFF v3 just came out, I think, 2 months ago, but BFF v4, we're working very heavily on that. And the main theme around that is what we call multi-frontend support. Now, we've also, we thought about calling this multi-tenant support, but a tenant is a very overloaded term. A tenant in one system means something completely different to another. But logically, what we're doing here is we have a single host, and we allow you to have multiple front ends supported in there. That can dramatically simplify your application landscape. Imagine if you have dozens of applications in your enterprise, then you have to deploy dozens of BFFs. And with this, you can simply just deploy one, and that all just works. We've added support for dynamically removing and adding front ends, which is really nice, so that you don't have to redeploy your BFF to get a new front end. Note, we didn't implement any database providers for this, but we really it's really straightforward to add that yourself if you want to. You can decide whether you want to have one identity provider per front end or share those. I mean, you are very flexible in your configuration. Logically, it could be just, there's multiple BFFs just physically located in the same host, or you can say, no, I want all the BFFs to behave exactly the same, using the same client ID and client secret, but maybe just with a different other identifier in your tokens. Now, in order to make this very observable, we've added OpenTelemetry support so that you can see exactly what's going on inside of the system. And we have a little bit of a scoop. Just today, we've released v4 Preview 1 on NuGet. So we desperately want your feedback on it as well. So please just go ahead, give it a try. We're going to do our best to create the documentation around this in the very near future so that it's easier to get going. But it is out there, and yeah, I'm very excited about this particular release. Now, after V4 has landed, there are some other things that we're looking at. One thing I can already do a little bit of a teaser is that we're looking to create development containers that just plug directly into Aspire, so that you don't even have to create the hosts that we did earlier, and you're not even able to create the mistake that I just did earlier. So that's much easier to get going. And yeah, we're very excited about doing that also in the very near future. All right. Again, we love your feedback on this. What you like, what you don't like, if there's anything that we can do better. We've already opened up a discussion here in the discussion forum, so feel free to do it there or just create a new topic. And yeah, let us know what you think. Well, thank you so much. And I hope this was useful.
Yeah, that was an awesome presentation, Erwin. If I had a React app in production, I'd be very scared right now. So, yeah, let's get to, I think a really, really good question asked in chat. Let's see if we can show it. I think a lot of folks out there are doing front-end development. They're probably storing access tokens in the browser, and they're probably confused about this particular issue. Could you please touch on why session cookie exfiltration is less problematic than access token exfiltration?
That is a great question. If you're able to do it, you get roughly the same behavior. So a session cookie maps somehow to a session, right?
Mm-hmm.
So from that perspective, you're absolutely right. The thing is, a JavaScript-based application cannot reach the cookie store to exfiltrate the session cookie.
Mm-hmm.
So your attack surface is just way smaller with access token, sorry, with session cookies than with access tokens, and that's where the problem lies. Now, if somebody, here's a word of warning: if you've installed all kinds of plugins in your browser and you give those plugins access to all the requests going back and forth, you will open yourself up to session cookie exfiltration, and you'll be still vulnerable to exactly the same type of challenges. So this is not a silver bullet that solves all the authentication problems. It's just a huge surface area that we're just taking out of the equation altogether.
Yeah, I will.
Sorry,
yeah.
Sorry. One tiny.
Yeah.
I know. You know how I love to keep talking.
Keep
one
going.
little thing. There is work in the specs to make sure that that session cookies are cryptographically tied to your device.
Mm-hmm.
At that point in time, when that hits, even if they steal your session cookie, they can't use it because you can tell that it's not bound to your device. Now, I'm very much looking forward to that, but that is still spec work. And as soon as that's out there, we'll do our best to support that.
Yeah. I will also add too, it's like when you exfiltrate an access token, it is something that someone can use right away. A session cookie typically is encrypted using ASP.NET Core's data protection, so it's like someone could use that session cookie potentially, like Erwin was saying, through a plugin, but can they pull information out of the session cookie? Likely not. Erwin, you showed that jwt.ms site. JOTs are just encoded, so you can decode them and look at the data that's inside them. Session cookies, no, they're typically encrypted, and you can't just do that because the private key is stored on the server. So that kind of is also a positive towards session cookies, at least how they're implemented inside of ASP.NET Core.
Absolutely.
Yep. Let's see. Here's another question. I'll get this question off the list here. Trying to go down. Let's see. Here we go. I think this gets back to still people trying to understand where the tokens are kind of being stored, but should the refresh token be sent as a cookie with each request in the case the access token expires? I guess this relates to how BFF is doing session management. Erwin, do you have any thoughts about should people be doing this or not doing this?
This is it depends, but it's a great
Mhm.
question. So if you, first of all, you don't have to use refresh tokens, right? I mean, if you don't use refresh tokens, you won't even have them.
Mhm.
If you store your authentication state in a cookie, then yes, you should also have the refresh token there. It is both. It is your access token, your refresh token, and they're being sent with every request. So yes,
Mhm.
in that case, if your access token expires, our library under the covers will detect that it expires, get a new access token for you, and just seamlessly continue without you noticing that.
Mhm.
If you're using server-side sessions, then it is in your session state that we have both your access token and your refresh token. And we're using just those then in exactly the same way, but it's just, so great question. Great
Yeah.
question.
I will say, like, this isn't a question, but really a comment that I had when watching you take a existing React application that was doing the OpenID Connect handshake in the front end and translating it over to BFF. I just noticed you were just deleting a lot of code from the front end, and your fetch request just seemed a lot simpler. Um, like, do you think a lot of people are going to have trouble converting an existing React, Vue, or Angular application to use BFF?
No, I don't think so. I mean, I've personally done this for pretty big, large-sized applications, and fortunately, I mean, very often developers put all of that code that adds those access tokens in the same place. So it's usually just one place that you need to touch for that. So it's on your startup of your application where you just remove a bunch of code. Just adding those CSRF protection headers, yeah, you do also want to have that in exactly the same place. And there's no way to automate that, because if you could automate that, then somebody, an attacker from another site would do the same thing. So
Mhm.
you don't want that to be automated.
Okay. Yep. Very cool. I think there's one more question. I think our staff is going to put it up here. Let's see what it is. Um, just waiting. The while we get that question up. Oh, here it is. So someone asks, we already have implemented YARP. So for folks who don't remember, YARP, yet another reverse proxy written by Microsoft. So is BFF.YARP, the NuGet package, needed to get BFF working?
No, but then the token exchange, when a cookie comes in and exchanging that for an access token, is something that you'll need to do yourself. Now,
Mm-hmm.
what I haven't demoed in this particular scenario, but it's very easy to do, if you have an existing YARP implementation, you can mark up those with additional markup to say which request and what kind of access tokens you want to attach to those. You can simply do a blanket statement saying they all need to have the user token, or they all need to have a client credentials token, but you can also go in granular and say that. But yeah, we fully support YARP itself. It's just we provide additional infrastructure on top of that to do that token exchange.
Yeah. I will also say, Bo, if you have like detailed questions or you want to talk about your specific setup, please head over to our GitHub discussions, start a
Absolutely.
question there, and we'll have a conversation with you. Also, it's good feedback for us. So if folks there already have YARP implementations, it helps us better figure out how we can support you as you try to move to BFF. So
Absolutely.
um, on that note, I think that's it. Let's start wrapping up here. We'll get the final slide on the screen. So let me do that. Let's skip through. So yeah, thanks again. This was an awesome live stream. Thank you so much, Erwin. I'm still amazed by that presentation, just how easy it is to kind of like pwn a React application. Actually scares me. So thank you again, Erwin, for this. I want to thank everyone in the chat who's been asking a lot of questions. If you want to continue this conversation, please feel free to leave any comments on the YouTube video or head over to our GitHub discussions. where you can start asking questions there about BFF or any other security questions that you have. I will also say check out our link here at duende.link/BFF for more information about backend for front-end security library. Go to our website if you have any questions. Be sure to follow us on social media. We have Blue Sky, LinkedIn, and obviously, if you, again, want to start any discussions, head over to duende.link/community. So on that note, I'm going to ask one more time, if you enjoyed this content, please leave us a like, comment, subscribe, hit that notification bell. And yeah, also leave a comment if there's any particular security topic you'd like us to cover in the future. On that note, I want to give a final thank you to Erwin, and hopefully we'll see him in the future.
Excellent. Thank you so much for watching, and thanks, Khalid, for an excellent intro and outro.
Yep. Thanks, everybody. Bye.